Today I'm going to introduce some concepts in magnetism. So we have some magnets, red on the north side, blue on the south side. All magnets have two poles, a north pole and a south pole. They are similar to the positive and negative charges in electricity, but this is magnetism. They are different, but they have similar ideas in which the north pole of one magnet is attracted to the south pole of another magnet and vice versa. So if we have one of these small magnets like this, and we have a larger magnet, we look at them, and the north pole is attracted to the south pole, and then similarly, they repel, but then it'll flip around. Then they have magnetic fields surrounding them, and I have a bunch of little compasses, and if you look at them, they all orient such that they are pointing toward the south pole. Now, some of them are pointing in the opposite direction. They've been reverse magnetized, but basically it goes from the north pole and they point towards the south pole. So as I move these, all of the compasses in here will move associated with that. So that's pretty sweet. Now, we also have a rare earth neodymium magnet, and if I put that on there, you'll notice that the magnetic field lines are slightly different, and you can see how the magnetic field changes as you move the magnet around. Okay? We can draw this magnetic field by using a magnet and a very small compass, right? I've got this tiny little compass, and let's see how that works. So with the compass, what I'm going to do is I'm going to take my bar magnet here, and I'm going to trace it so I keep it in the same location. And once that is done, then I'm going to bring this magnet nearby, and I'm just going to put a little point near the south pole and the north pole. And then I'm going to move it and point the south pole towards my previous dot, put a new dot where the north pole is, put a new dot where the north pole is there when I line up the south pole. And now this is a magnetic field line that this compass has helped me draw. So I can draw one here, and it's going to go a little farther. There we go. And so this one kind of goes more around here. And there you go. And then let's just do one more. If we start it way up here, then it's going to curve ever so slightly, but it will not come back on the paper. It'll just be larger than the paper, right? So this magnetic field line is going out like that. If you do one directly above the magnet, it's just going to be a straight line. So just magnetic field line going that way. So that's how you draw magnetic field lines using a magnet and a small compass. Next, we're going to show how a moving charge creates a magnetic field. We use the first right hand rule. So my right hand, if the current is going in the direction of my thumb, the magnetic field will go around the wire in the direction that these fingers are pointing, around the wire like that. So if we look at this little setup, I've got a wire that's coiled around here, and I'm going to connect the two ends of the wire to a battery, and we're going to see what that does to the compass. The compass is currently pointing to the north, and what I'm going to do is I'm going to connect the wires in 3, 2, 1. Now there's a current flowing through the wire. It is causing there to be a magnetic field that goes through the wire in this direction. So, and that's because the current is flowing around, going nearest the video camera. It is going in this direction, and then it goes down. So what I can do is I'm going to reverse the poles, right? So here's what we have. So I connect the battery, and now the wires make a magnetic field that pushes the compass needle. So if I flip the battery around, I'm using 2 of them to get a stronger magnetic field, and I flip it around, and of course the magnet is going to be in a magnetic field that is the opposite of what it just was, so the north needle will point in the opposite direction. Next up, I've got a magnet, a strong neodymium magnet, and a solenoid. All a solenoid is just copper wire wrapped around and around and around and around. And when I put a current through this, then there will be a magnetic field going straight through the middle of the solenoid. So I put the magnet into the solenoid, just like that. Connect both sides. So I've got one side connected to the negative. The other side's going to be connected to the positive. Let's see what happens. It moves in. So the magnetic field pushed the magnet. Now, I flipped the magnet around. It was like this. Now it's facing like the opposite direction. And when I flip it, it does this. And it shoots out. So the magnetic field was reversed, so it pushes the magnet out because the solenoid, the fact that current was going around the wire, that caused there to be a magnetic field going through the middle. And this is the fundamental way that electric motors work. You get moving current, generally supplied by a battery, causing a magnetic field that goes through the middle. Now, when you put a piece of iron in there, it will actually multiply the magnetic field, and that will make the magnetic field even stronger. So I'm going to show you a very simple motor. So here is the base of it. I've got a battery in here. The positive terminal is connected over here. The negative terminal is connected to this side. And there's a magnet right here. And so when I just take a coil of wire, the current is going to go around the coil of wire, and then that magnetic field is going to interact with the magnetic field of the magnet, and we will see how that works. And there you go. Didn't even need to push it, and it's already going. So this will go as long as that battery provides a current. Here is the battery connected to a coil of wire. It's creating a magnetic field. You notice that the magnetic field is pushing, and now the magnetic field of the current flowing through the wire is interacting with the magnet that's sitting there, and this is basically the simplest electric motor you could ever make. And that'll keep going as long as there is current flowing through the wire. Once the battery runs out, it'll no longer keep running, but very little current is necessary for this magnetic field to happen. Nice. As you can see, it's not super easy to make it go. Just bend that a little. Okay, now.